Welcome to the third and final video for our digestion chapter. In this video, we're going to go over how nutrients are absorbed from the digestive system once they're broken down, how they enter our cells or our bloodstream. We'll talk about the idea of you are what you eat in terms of, necessary nutrients and molecules that we need to put into our bodies. And then we'll look at some diseases and finish up with kind of the diseases that can affect our digestive system. Okay. And so the nutrients that our digestive system is absorbing are things like amino acids, monosaccharides, lipids, water, vitamins, and minerals. Okay, and these are going to absorb differently depending on on what molecule we're looking at. So amino acids come from the breakdown of proteins, and these are absorbed via active transport. Okay, so there has to be energy to transport these amino acids into the cells and into our bloodstream. Monosaccharides come from carbohydrates and are also absorbed via active transport. Lipids are broken down to monoglycerides and fatty acids, which are then reabsorbed or absorbed and reassembled into triglycerides. So basically, they're triglycerides after they're broken down, and then they're triglycerides. They enter our body. The biles will break them down into their monoglyceride form, so like their monoglyceride heads and the fatty acid tails. They'll be transported into the cell, and then they'll be reassembled into triglycerides. Well, they'll then be used wherever they need to be used in the body. Water will be absorbed via osmosis, so that osmotic gradient that we've talked about, so from from low to high solutes. And then vitamins and minerals are going to be absorbed differently depending on the vitamin and mineral that you're looking at in that process. Okay. So here we have an image just kind of showing this. So you have your proteins broken down into amino acids, actively transported into the cells and then into the bloodstream to the hepatic portal system. You have your carbohydrates broken down into monosaccharides the same way, actively transported into the bloodstream to the hepatic portal system. For the fats, you have your bile salts that will emulsify those droplets, breaking them down into smaller droplets. They will be brought into their monoglyceride and fatty acid forms, reassembled into triglycerides, and then they're transported into the lacetyl, where they'll then be taken to various places throughout the body. Okay? And so what we have in this animation is kind of a summary of everything we've talked about up until now. Okay, so it's basically going to go over kind of stuff from the first and second video and then what we just mentioned at the beginning of this video. Okay.
Digestion takes place in the alimentary canal, also called the digestive tract or gastrointestinal tract. Basically, this structure is a tube that starts at the mouth and ends at the anus. Several vital organs and glands are connected to the alimentary canal and contribute digestive enzymes and other products to specific portions of the canal. Food is processed mechanically and/or chemically, depending on where it is in the alimentary canal. Mechanical digestion begins in the mouth, where the teeth grind down food, thereby increasing the surface area that's exposed to enzymes within the mouth. Chemical digestion also begins in the mouth, with the secretion of saliva from salivary glands located underneath the tongue. Saliva contains the enzyme salivary amylase, which breaks down carbohydrates. The esophagus transports food to the stomach, where mechanical and chemical processing continue. Food then enters the small intestine, where chemical processing is completed and the absorption of nutrients begins. The liver secretes substances required for the digestion of fats, and the gallbladder stores these substances before emptying them into the small intestine. The pancreas secretes enzymes and other substances into the small intestine to carry out chemical digestion. Finally, what's left of the food makes its way through the large intestine, where water is absorbed and feces are formed. Animals don't acquire nutrients as individual molecules, but instead must digest their food internally. They must extract nutrients from the food and eliminate wastes. Let's follow a meal as it travels through the alimentary canal. For simplicity, we'll divide our meal into its main macromolecules: carbohydrates, proteins, and fats. Digestion begins in the mouth, where both mechanical and chemical processing occurs. Chewing reduces the size of food particles, and enzymes secreted by the salivary glands begin the chemical digestion of carbohydrates. Once food is swallowed, a wave of muscular contractions called peristalsis propels the food particles through the esophagus to the stomach. Mucus secreted by cells that line the esophagus helps protect it from abrasion and lubricates the food during its passage. The human stomach is an expandable muscular sac capable of holding from 2 to 4 liters of food and liquids. Food is retained in the stomach by a ring of circular muscle, the pyloric sphincter, that separates the lower portion of the stomach from the small intestine. When food enters the stomach, muscular contractions churn it, mixing the stomach contents and reducing them to a soupy mixture of food and digestive enzymes called chyme. Most of the chemical processing that occurs in the stomach is the digestion of proteins. The gastric juice in the stomach is highly acidic, having a pH as low as 1.5. This acidic pH hastens the metabolism of proteins. In addition, many digestive enzymes are secreted by stomach epithelia. Mucus lining the gastric epithelium protects the stomach cells from denaturation and from damage by the stomach's own acid. The muscular churning also helps break up fat. However, because fats are insoluble in water, they tend to aggregate into large globules as they're churned. Peristalsis in the stomach walls moves small amounts of the partly digested material into the small intestine. There, secretions from the pancreas, including a form of amylase, are added to the mix. Pancreatic amylase continues the digestion of carbohydrates that began in the mouth. The cells lining the small intestine absorb the sugars that are broken down by pancreatic amylase. The epithelium of this organ is folded and covered with finger-like projections called villi. The cells that line the surface of villi have projections of their own called microvilli. The folds, villi, and microvilli of the small intestine greatly increase the surface area available for absorption. Nutrients such as glucose exit the lumen of the small intestine and enter the epithelial cells. The absorbed glucose exits the epithelial cells and enters the bloodstream, which carries it throughout the body. Protein digestion is completed in the small intestine with the aid of pancreatic enzymes. By the time the partly digested food reaches the end of the small intestine, short polypeptides have been broken down into individual amino acids. Cells lining the small intestine absorb amino acids in much the same way as they absorb glucose. The bloodstream then carries the amino acids to individual cells throughout the body. In addition to pancreatic amylase, the pancreas also secretes the enzyme pancreatic lipase. Lipase breaks down fats. However, before the molecules in the fat globules can be digested by enzymes, the globules must be broken up or emulsified. Bile is secreted by the liver and stored in the gallbladder. The gallbladder releases the bile into the small intestine, where the fat globules from food, lipase from the pancreas, and bile salts from the liver come together. The bile salts emulsify the large fat globules into small fat droplets. Fats that have been emulsified have more surface area exposed than do large clumps of fat. Thus, secretion of bile into the small intestine facilitates digestion because smaller emulsified fats are easier for enzymes to gain access to and digest. Pancreatic lipase breaks up the small fat droplets into monoglycerides and free fatty acids. Once fatty acids have been liberated, they're processed into protein-coated complexes and released into the bloodstream for transport to fat storage cells and other tissues throughout the body. By the time the processed material reaches the large intestine, much of the water and virtually all of the nutrients have been absorbed. Additional water is absorbed in the large intestine, and the solid material is compacted to form fecal waste.
All right, so that was a pretty lengthy video, but again, it went over pretty much everything we've talked about up until this point. So it's really good study video, really good animation for that. Okay. So what we're going to go into next is looking at how digestion is regulated. Okay, and the regulation of digestion is really dependent upon the volume and the content of food that you eat, right? So if you eat a lot of fats or if you eat a lot of proteins, right, your body's going to have to deviate the digestion process towards that type of food. And so in general, though, the nervous system has stretch receptors in the stomach. And as the stomach stretches, the reflexes increase the peristaltic actions and causes secretion in the gastric juices. Right? So you also have hormones that are released. So you have gastrin, which is released by the stomach, secretin, which is released by the duodenum, and then choleocytokinin, never can say that one, which is released by the duodenum, so also the small intestine. Now, each of these have a pretty different function. Gastrin is triggered to be released when that stomach stretches and when there's a protein present in the food. This causes the gastric juice to be released by the stomach. Okay. The secretin that's released in the small intestine is triggered by the presence of acid in the chyme that enters the duodenum. And this tells the pancreas to secrete water and bicarbonate. And then the CCK is triggered by the presence of fat and protein in the chyme as it enters the small intestine. It tells the pancreas to secrete specific digestive enzymes, and then also tells the gallbladder that it needs to release bile because of the fat and the presence of that fat. Okay. So depending on what you eat, the presence of proteins, fats, etc., determines what's going to be released during the digestion process. And so looking at nutrition and kind of continuing with the discussion of your digestion is somewhat based on what you eat, like which enzymes are released, etc. Nutrition, by definition, is the interaction between an organism and its food. Right? So you can look at what an organism eats and define its nutrition based off of that. Now you can do nutritional planning, and there's lots of nutrition guides, etc., about what you should eat in terms of having this particular diet, etc. And one other source is one called choosemyplate.org. You have your foods divided into 5 different food groups, provides recommendations from each group. You can put in your individual stats, so like your age, your gender, your height, your weight, how much physical activity or exercise you do on a daily basis or not do. And then it can recommend or provide some recommendations for you. However, in general, it's pretty recommended to have a healthy diet, for you to eat a variety of foods and not to focus on one specific food type. Because while one specific food type can be good for you, moderation is everything. So everything in moderation is really like a true statement here. You want to maintain a healthy weight. You want to eat plenty of fruits, plenty of vegetables. You want to look at whole grains, what you kind of want to focus on. You want to consume sugar only in moderation, especially refined sugars. Salt, sodium in moderation. We do need it for our bodies to function, but we also don't need a lot. And then any other things that could be potentially harmful or increase your risk, just do so in moderation if you like it, right? Looking at where a lot of our nutrients and molecules come from, right? We can look at our organic molecules that we talked about, say in what was that, chapter 2. And so, for example, remember our carbohydrates are our big source of energy. That's our primary source of energy, right? So that's your glucose molecules. For a caloric intake, 45 to 65% of those should be carbohydrates, and they should be so you should focus on your non-refined sugars, right? So you have your simple carbohydrates, which are your sugars, and then your complex carbohydrates, which are your, polysaccharides, so like your starches, your glycogens, your fibers. And you want whole foods that provide complex carbohydrates over those simple carbohydrates. So again, like those refined sugars. In terms of lipids, you have your saturated fats and your unsaturated fats that we've mentioned already earlier in the semester. Remember, your saturated fats are solid at room temperature. You get this from like your meats, your dairy products, and they have the LDL, so that bad cholesterol. And then your unsaturated fats, which are liquid at room temperature, come from things like your plants, such as olive oil, corn oil, canola oils. Also, certain fish have really good unsaturated fats. And the unsaturated fats tend to be linked to like your quote unquote good fats. They have the lower amounts of bad cholesterol, and they tend to reduce your risk of heart disease because having the high LDL can really increase your chances of having the atherosclerosis, where you get blockages in your arteries. And then your trans fats also can give high levels of LDL. And remember, those are produced by hydrogenating the vegetable oils, where they're taking those unsaturated fats and hydrogenating the hydrogens onto those vegetable oils. In terms of proteins, there are proteins that are known to contain every single amino acid, and those are known as complete proteins. There are 20 different amino acids. 12 can be made by the human body, so that means there are 8 amino acids that we have to get from food sources. Complete proteins have all 20 amino acids. That's going to be like your soy protein and most of your animal proteins, your meats. Incomplete proteins lack at least one essential amino acid, right? And a lot of these are your plant proteins. But with your plant proteins, you can consume a variety of plants to make a complete diet, right? So, for example, if you want to eat only plants, then you could eat something like almonds, right? Because they are low in lysine. And then you can supplement that with maybe like mushrooms or lima beans or lentils, which are low in methionine. And so they kind of compensate each other. Now you're getting all of your amino acids that you need by mixing kind of what food you're eating. Complete proteins, though, again, a lot of animal products are complete proteins, so like your meats, your fish, dairy products like cheese, eggs, yogurts, your wheat germs, so like your cereal grains, and then your legumes, so like soybeans, soy milk, gives you all of the proteins you need. And then this is just a list of some that show you kind of what they're low in. And so again, you can kind of pick and choose and supplement each other in regards to the complete proteins. Vitamins are essential for normal function, so at least 13 different vitamins are needed. You have two different groups of vitamins. You have fat-soluble vitamins and you have water-soluble vitamins. Fat-soluble are absorbed with fats and stored in adipose tissue, so they're stored in your fat tissue themselves. Water soluble is only stored briefly, and we have to consume those water soluble vitamins on a regular basis because our body can't store those water soluble vitamins like they can store fat soluble vitamins. So, for example, fat soluble vitamins are vitamins A, vitamins D, vitamin K. Water soluble vitamins are like a lot of your vitamin B variants, vitamin C, your folic acid. Again, so depending on the type of vitamin determines like how often you should consume that vitamin. In terms of minerals are really essential for a lot of the body's processes. There's 21 essential minerals. And if you remember, we've already talked about quite a bit. So we need sodium, we need potassium for the sodium-potassium pump. You need iron for your hemoglobin. You need calcium so that your neurotransmitters can be released and so that your muscles can contract, right? And that's just a few. And so the minerals are really important because they're, playing roles in the ones we just mentioned. And then calcium's also in the structure of bone, phosphorus as well, nerve and muscle activity, right? It's that sodium potassium pump, and then the calcium for the neurotransmitters. And so there's a recommended dietary allowance, or an RDA, which basically says how much of each vitamin, mineral, an individual should consume on a daily basis. Okay? Here's a list of major minerals from the human body. This is not a full list. Common sources where you can get that mineral, what functions they're for, and then signs of some deficiency, and then signs of excess with that specific mineral. And so you don't have to memorize this table. This again is just for your information. Now, fiber benefits the colon because the vegetables, the fruits, and the whole grains that you eat that are not really digestible contribute to bulk feces, and it helps for you to get rid of the waste that is stored in your large intestine. And so you can really have problems if you have a low fiber diet. You don't have anything to contribute to that bulk feces. You'll get chronic constipation, you can get hemorrhoids, and you also can be at a higher risk for colon cancer if you don't have quite a bit of fiber in your diet on a regular basis. So what we're going to look at now is kind of an energy balance, right? So we all know that we need to take in carbohydrates, we need to take in fats because there are these energetic molecules that allow us to run and be active and basically, do our daily functions and let our cells do their daily processes. Now, the amounts of energy that you need to perform your essential activities is the basal metabolic rate. And this is the energy for all of the activities minus any physical activity. So this is just to keep your body going on a daily basis. Your basal metabolic rate determines how many calories you need on a daily basis. Now, your metabolic rate is determined by a couple of different things. It's determined by your gender and your body composition, your age, your health, your food intake, and your genetics, right? Generally, as you increase in age, your metabolism goes down. So your basal metabolic rate slows down. So you don't break down food as fast. Your body's not using those energy sources as fast. Your genetics can determine whether you have fast or slow metabolic rate. How much food you intake, the type of food you intake can affect that. Your overall health can affect your basal metabolic rate. Right? Most people have a daily energy expenditure that is 50 to 100% higher than what's needed for their basal metabolic rate because we do physical activities. Physical activity says, we're using more energy on top of our initial basal metabolic rate, so we need more calories to compensate for that energy expenditure. So we have to balance our energy intake with the amount of energy we use on a daily basis. If you take in more calories than what you expend, then those calories are going to be stored, and they'll be stored in the forms of fat, and which can lead to weight gain. And the number of fat cells that you store is also determined by adulthood. As you get older, you tend to store more and more fat. Losing fat actually shrinks the cells, but they can refill very easily, making it very difficult to lose weight. So if you lose weight, you could gain it probably faster than you did initially because they refill fairly readily. Every 3,500 calories you use during physical activity generally equates to about a pound of fat loss. But again, this can be different by an individual on per individual basis, right? Because there's a lot of factors that go in determining that. Healthy weight is really important because if you're at a healthy weight, you can reduce your risk for a lot of different diseases. For example, heart disease, diabetes, specific cancers, arthritis, and back problems, joint problems. There's a lot of things, a lot of complications that we get that we could really lower our risk for if we focused on healthy diets. Now, I know that's hard. It's difficult to do that. I'm not saying, you need to do this because, I love soda. That's kind of my Achilles heel. I like hard candy. And so, I have my issues with diets and stuff too. So I'm by no means like preaching a tune off, just kind of giving you some facts. But what we can do is we can look at our height and our weight, and we can get a BMI, or what's known as a body mass index. By looking at your height and weight, you fall into a specific BMI category. If your BMI is between 18.5 and 25, you're classified as having a healthy weight. Now, if you have a BMI of 25 to 30, then you're technically considered overweight, and then a BMI of 30 or greater, you're considered to be obese. And then your risk for those different factors increase as your BMI increases. So getting towards the obesity part of that BMI scale. Now, just because you have a BMI at a specific index doesn't necessarily mean that you fall into these categories, because, for example, you could overestimate body fat in a very muscular or heavy boned person. So muscle is heavy, and so you could be muscular at a specific height and be in an overweight category that would not be correct. Right? But you may also underestimate body fat in people who have lost muscle mass. And so it can go both ways. Right? So here we have a figure showing the BMI index. So you would basically look at your weight in pounds, look at your height, and then find out where you fall on this body mass index. And that'll tell you whether you're underweight, healthy weight, overweight, or you fall in the obese category. And so obesity, I just want to touch on for a second. It has increased in the United States from about 13% to 36%. This data is about a decade old. So I would actually imagine this to be even higher now. And one of the big problems with obesity is that, we're in an environment that really favors the imbalance of caloric intake. So we're in an environment that favors kind of the sedentary lifestyle, and the lifestyle where we can sit at our desk, do our work, etc., not be active, watch TV, play video games, etc. And we take in much more that we're spending, which leads to a higher incidence of obesity. Right? We also have inexpensive, high caloric food, right? If you don't have a lot of money to spend on groceries, then you really can't afford to buy healthy food. Healthy food is expensive, which is outrageous, right? It shouldn't cost more to eat unhealthy than it does to eat healthy. Right? That's a completely different topic. Me and my wife discuss this all the time. So that combined with the decreased physical activity really leads to higher incidences of obesity. So now here's an image showing kind of the increase of obesity across the United States from 1990 to 2010. So this is kind of where that data is coming from. And you can see the darker the red, the higher the incidence, over 30%. You can kind of see where that obesity is kind of focused. Now, just to finish up, some eating disorders, some disorders of the digestive tract. So eating disorders we have really just characterized by abnormal eating habits, and this actually causes damage to an individual's health. And we see a lot of it in young women living in industrialized countries. Some of the eating disorders that they experience are anorexia, bulimia, and then also binge eating. Anorexia is where you have excessive dieting, to where you're almost starving your body. It can potentially lead to death. Bulimia is where you binge eat. That's followed by purging, which is basically just vomiting or using a laxative to get rid of it from your body as fast as possible. Or you could just have a binge eating disorder where you binge eat food. Maybe it's like emotional binge eating or some other reason, right? Generally, though, with these three types of eating disorders, there's this underlying emotional issue or mental state that the individual should discuss with a professional about. Usually it's much more complex than what we see at the surface level of those individuals. Now, disorders of the digestive tract. So one is lactose intolerance, so just a difficulty in digesting milk because the person or the individual doesn't have enough lactase enzyme to break down that lactose, so that causes difficulty in digesting the lactose in the milk. Peptic ulcers, which is caused by an infection of a specific organism. Celiac disease, which is basically gluten intolerance, which can cause some issues. Diverticulosis, which is weakness in the wall of your small intestine. And then colon polyps, which is where you have non-cancerous tumors that grow in the mucosis area. But you can get colon cancer to form in the colon itself. Also, hepatitis in terms of disorders in the accessory organs. So this is in the liver. There's three versions of hepatitis caused by viruses. You have hepatitis A, B, and C. They can each be transmitted through different processes or pathways. And then the last one that we're just going to mention is gallstones, which is where you have crystals to form in your gallbladder, and they can really obstruct the flow of bile and can cause problems and can be painful. And the doctor would just go in and if they can't break up the crystals and it's severe, then they would just remove your gallbladder to help get rid of that instance and disease. And so that's it for our digestion lecture. As always, let me know if you have any questions, any concerns. I hope you have a good rest of your day, evening, morning, whatever time you're looking at this, and we'll see you in the next module.